Okay, let's read the file that we created in the previous video. Now, the approach I'm going to take here is to read the entire contents as one huge string, right? And there's lots of reasons why you'd probably want to do that. So this will probably be a little bit different approach than what you see on other YouTube videos. But I'm just going to treat the data as if it were binary data. Okay, so let's first take a look at the algorithm for how we're going to approach this. Okay, and it's always a good idea, right, when you sit down to do some programming, that you kind of think about how you're going to approach the problem and then write a few steps, right? So okay, so the way I'm going to do this is first, as you saw in the how to write strings to a file, you need to declare a file pointer. So that's the first thing you need to do. Then the next thing you need to do is to declare a char pointer to an input buffer. So the input buffer will be dynamically allocated to contain as much memory as required to hold the contents of the file, right? And then you need to open the file for reading, and that will be using the file mode R. Then next thing you need to do is you need to figure out how long the file is, or what's the length of the file. And you do this using the combination of two methods: the fseek, where you're going to call fseek and you're going to move to the end of the file, and then you're going to use the ftell method to tell you how long or how many characters are in this file, right? Or how long that file is. Now, a file contains bits and bytes, right? What that file contains is totally up to the developer, right? So if I put strings in there, then I know I'm going to get strings out. Well, you don't put strings per se, you put characters. And so in the last video, we wrote a series of characters, right? A series of characters is called a string, right? So we know that there are characters in this file. There could be, from A to Z, from capital A to capital Z, and there could be white space like /n or /t, whatever. But it's character data, so we know we're going to get character data. Then the next thing you do is, once you know how much or how long your file is, you're going to dynamically allocate enough memory to hold the file contents. And that's where the input buffer comes in. You're going to use the malloc method to dynamically allocate enough buffer space, or an array, essentially, large enough to hold the file contents. And then you're going to read the file contents. So let's get to it. So the output.txt file that you see on the screen now, that's the file that I created in the previous video where I explained how to write strings to a file. And I'm going to be using that. So I just copied it from the last project folder. Okay, so I'll just close that. Now I'm going to start with a new file, and I'll just call it read file C. Okay, hit return, and I'm going to start, as I usually do, with a header. So to demonstrate reading an entire file into a dynamically array. Okay, or I should just say character array. Now this can look intimidating, right? Because there's a few moving parts, and I'm going to actually put the part that reads the length of the file and dynamically allocates the buffer into its own separate function. Okay, but otherwise it should be pretty straightforward to follow along with what I'm going to do. Now, first thing we need to do is we need to import or include, right, the standard IO. Well, let me get that right. Standard IO.h and include standard lib. Now that we know in the previous video we explored these header files. So you should be familiar with what they contain. So .h. Okay, now I'm going to just flesh out the main here, and we'll come back to the function prototype in a second. So int main, open brace, closing brace, return 0. All right, so just keeping that algorithm and the series of steps in mind, I'm going to start with declaring a file pointer called fp, right? Like again earlier, you can name this thing anything you want, but I always initialize mine to null before I actually create it. And then we need a character pointer, and I'm going to call it input string. We could call it input buffer, but I'll call it input string. So char input string. Okay, input string equals null. And then in here, I'm just going to put a comment. Well, first off, let's go ahead and open the file. So fp equals fopen. And I'll just hard code the name. So it's output.txt. And the mode that we're going to use is to read it, right? We're not going to be sticking any data into it. Like that. Okay, and then here, I'll say if, so if that's successful, right, we've opened that file, fp, then a sum operation is going to go here. And so I'm just going to put a comment. I guess I should say, read the file and print out its contents, right? So that's exactly what we want to do. So read the file and print contents to the console. So this is just going to be a placeholder in the code. Okay, now once we're done with the file, then we need to deallocate. Okay, so I'm going to put another comment here called deallocate. Deallocate character array. Now it's going to be the other function that actually allocates it, right? But we need to make sure that we free that memory up. When you deallocate memory, make sure you free it up. So I'm just going to check it. So if input string, and if that is not null, then I'm going to say free input string, and then I'm going to set it to null. Just like that. Now, with the file, if you open a file, somehow that got in there. So let's make sure we fix that. There we go. Okay, that shouldn't be too annoying to you now. So we're going to check if fp, right? If that got allocated. Oops. Open brace, closing brace. Then we're just going to call fclose on fp, and we're going to just set fp equals null. And that's pretty much fleshed out. So the big mystery is, you know, what comes here, right? So I'm going to create, in fact, I'll split this up, this comment. So read the file and initialize read file. So you're going to read the file, and we're going to load the contents. I'll just say read file into input string buffer, right? And then print contents, print input string contents, right, to the console. So that'll be 2 lines of code there, but it makes it clear what we need to do. So a lot of times this is how you like you know, do coding, right? You know what you want to do, you know how to do some of the stuff, but you don't necessarily know how to do the rest. So I'm going to save that file, and let me see. I'm getting oh, this is a capital no, like that. So make sure those are correct. All right. So, all right, now I'm going to create a function that does the read file into input string buffer. All right. So up here, I'm going to create a, I'm going to put my function prototypes. So there we go. And so then, so this function is going to return a pointer to the buffer that contains the string. All right, and it'll be called read. You could call it anything you want, but I'm trying to name this function, you know, what it's going to do. So just read file like that. All right, and it's going to take, obviously it needs the file to read. So we're going to pass into it a file pointer. I'm going to call it file like that. And I'm going to, then you're going to need a, you need to pass in the buffer that you're going to create, right? So that will be char, right? Pointer, and I'm going to call it buffer. Buffer. So that is the prototype. Now you can go one step further here and you can add some documentation to it, which I'll do, right? So read file. Okay. And I'm just going to say returns a pointer to a character array containing, and then come down here on the next line, containing read file, containing the entire contents of the file. All right. So that's what that function is going to do. Now that we have the function prototype, we will need to create the function. So we come down here below the main, and I'm going to save it, and then just come down here. So again, char pointer read file, read. I got fat fingers today, so file pointer fp, and then char pointer buffer. So open brace, closing brace. Now here's where, so then we refer back to the algorithm. So we have our file pointer declared. We've opened the file for reading. We have our input string, which is going to be our buffer, right, declared. So we're going to pass the input string in where this buffer parameter is. And it's going to return, it's going to read the file, figure out how many bytes are in there, and then load that entire thing. Well, first off, dynamically allocate enough space to hold all the contents, and it's going to read it as a size of chars. Okay, so that's pretty much the step, right? So here we go. So the first thing we're going to do is we're going to call fseek, F-S-E-E-K, right? We need to pass in the file. Well, let me come up here. So FP, right? I could, you know what? I'm going to call that file. So just to be consistent with what I'm doing here, I'll call it, yeah, that, see, I named it file up here. I'm just going to put it file down here. All right. So file. All right. And I'm going to set the offset to 0. And there's a constant in the standard io.out, standard io.h called seek end. So you want to, I'm going to seek to the end of the file. And then I'm going to declare an integer variable called length. And I'm going to call the ftell and pass in the file. And that will return the length of that file, okay, in bytes. Now, then we need to seek back to the beginning, okay? So you know what I'm going to do? I'm going to comment as we go here. I think what I'll do is I'll put the comments here on right at the end of each line. Seek end, seek to EOF, right? Seek to the end of file. Get length, file in bytes, and then seek back to the beginning. fseek, right? File 0. This looks a whole lot like the first fseek, except we're going to seek set. So we're going to set to the beginning of the file because we want to read the entire thing. So let me just comment here. I should just say seek, right? So you're moving a file pointer essentially when you call this seek. All right, now that we have the length, we can then use the length to dynamically allocate. So I'm just going to put a function in here, a print, so we can see what the length of the file is. Probably, you know, this is a side effect, right? So you don't necessarily want to put a lot of printf statements all around your code. But when you're first learning how to program, it's nice to be able to see what's going on. All right, so I'm just going to say file length is, well, I'll just say equals, and then percent d slash n. All right, and then comma, length, like that. So we should be able to seek to the end and get the length. And then once we have that length, then the next thing we want to do is allocate memory for the buffer, right? So we've got a pointer to a char pointer coming in, right? But that thing is not set. It's not initialized, so that's what we need to do. We need to say buffer equals malloc, right? And then we're going to say size of, because we know we want to read the chars, right? So size of char, that's the size, times length plus 1. Now the reason we need a plus 1 is because there's going to be we need to leave room for a null character for the end of the string, all right, in the buffer. So semicolon, all right. So size of char, let's make sure that we've got everything here. Size of char, so malloc, so buffer equals malloc, oh, size of char, all right, buffer. Let me just return here. Oh, so printf file length, oh, size of. See, when you're sitting too close to the computer, you can barely see what the issues are. You guys on the YouTube are like, size of, not size, size of. Now that we have that memory allocated and the buffer contains enough space, then we're going to say, you know, if the memory allocation went well and that buffer is not null, then if that buffer is actually been allocated with something, then we're going to say size t elements read, okay, because that's what the fread method, you'll just have to go consult the documentation on that fread method. Fread, okay, so it takes in you see right there it says we need a pointer to a string. The documentation says this is where you pass in the buffer that's going to hold the contents of the file. All right, and then the next one is size. We see size t in blue underscore underscore size. This is asking, like, what size do you want to read each of these, all this data? Do you want to read each one as an integer, which would be, you know, 4 bytes? Do you want to read it as a char? Do you want to read it? So we're going to go size of char because we want to read each element in this array as a char, right? Remember now we're just assuming it's all binary data. and then length again. Okay, and then we pass in the file, so file, like that. All right, so let's just review that. Size t. Now this size t is provided for us in the standard.io.h file. All right, so it's an unsigned long, and it's like a type def for an unsigned long, right? But it's size t. So when this fread returns, then we're going to have the number of elements read, right? So we can print this out. So printf, all right, and we'll say elements read equals, and then %. And then because this size t elements read is unsigned long, we have to go lu for our, and I'll do \n for the conversion, for this conversion operation here, right? And then elements read. Okay, semicolon. And then the last thing that we need to do is return the buffer. Like that. So let's just review this one more time. Fseek, we're going to go seek to the end of the file. We're going to get the length with the ftell function. We're going to then seek to the beginning of the file. And then we're going to allocate, now that we know what the length is, we're going to use that length to allocate enough memory in our buffer to hold the contents of that file. If that allocation is successful, then we're going to read with the fread function the entire contents of the file, stuff it into this buffer, and we're going to read it as a series of chars with the length that we obtained from the ftell and on that file, right? So we're passing that file in as an argument, and we're passing the buffer in. Okay, the buffer, like I say, is not allocated when you pass it in, so that's why we have to do this buffer allocation here, right? And then we return the buffer, and so now what we have to do is we have to go up to our main function, and we need to fill in the blanks here, right? So we can say input string, input string equals read file, and we're going to pass in the file. Let's go up here. So we got an FP. We're dealing with FP up here, right? So FP, and we're going to pass in the buffer. So input string, like that. Hit return, and then print the contents to the console. So printf, and I'm just going to print everything, right? So don't have to say what it is. So %string, and I'll follow that with a /n at the end, and then comma input string, like that. Now I'm going to compile this thing and just cross my fingers I didn't make any mistakes. So come up here. All right, so let's go to the terminal and clear the screen, do a dir. All right, so cd file io and read strings dir cls. So we've got the read file.c. So I'm going to say gcc-o read file.o read file.c. All right, so miracle, everything compiled, and then run it. All right, so then read file.o and drumroll. So that's it. The file length was 419, elements read 419, chars. I wonder if we counted these. I'm not sure if that's bytes or chars. I'm gonna have to go look, right? So it could be bytes. But anyway, this is it. This is the entire string, and of course, the string contains the /n characters, right? And so then I added another one at the end when I printed this. So there we go. Once again, just to review the algorithm, okay, we're going to create, let's just review the code real fast before we call it quits. We created a file pointer, and I initialize it to null. A char, an array, essentially a char pointer, right, which will be then point to an array of chars, but that gets dynamically allocated in the read file function. And then fp open, so we open the text that we want to read, and if that if the fopen is successful, then this will not be null, right? So we do fp, and if everything is fine, then we read the file and it returns the input string, right? And then we just print that input string. And then once that executes, then and even regardless, right, if input string actually contains something, then we're going to free that memory, all right, that pointer, and the input string, and set it to null. And then if file pointer is actually been allocated or created, then we're going to close, because anytime you open a file, you got to close the file. So I'll just put a comment up here just to make sure. Close the file. And then this is your read. I'll put a comment here. Read file. That's your read file function right there. Use the fseek to go to the end of the file, ftell to get the length, and then seek back to the beginning. And then print. I'm just printing the length here, right? You can do without that once everything is working. Dynamically allocate the memory, right? Dynamically allocate buffer space. All right. And then if that buffer is successful, you do read the file. Read file as chars, like that. Okay, I hope you found this successful, and one more time on the way out, we'll run it one more time. So let me just return to the console, clear the screen. I'm going to recompile it since I added some stuff to it. All right, and then run it. And that's what it looks like. It just reads everything in one fell swoop. Now, this may not be what you want if you have like boatloads of stuff, like megabytes and megabytes or gigabytes of stuff in your file, right? You may want to read it like one string at a time. But usually for moderately sized files, it's good to just load everything in memory and start manipulating it, right? So that's why I went with this approach, to show you how to do it. And of course, you can do this approach. Doesn't have to be strings. It could be a file full of ints. It could be a file full of imagery, right? You just got to figure out what it is that you're reading, and just read it, right? That's why I like the fread, right? It's all treats it like binary. You just got to figure out what it is. And that's it. I hope you enjoyed this video, and I will see you in the next one.